You can see. Okay, so I'm presenting my screen, your entire screen. Dim display, share, share. ठीक तो इसमें see- but was there any other difference than that or just that one?
That's what I thought actually. When I first saw it, okay, definitely they're going to just if they're changing that there in the next line they're going to swap too. But no, the next lines are not swapped. Everything else is same.
Simulated annealing हाँ इसमें क्या है कि हिल क्लाइंबिंग एल्गोरिदम नेवर fit to it. I hope you are able to see it, right?
Yeah, yeah, I'm
हाँ
seeing this thing.
ठीक तो in simulated annealing, it is said that the hill climb algorithm that never makes downhill move towards the states with lower value or higher cost is guaranteed to be incomplete because it can get stuck on local maximum. In contrast, a purely random move that is moving to a successor chosen uniformly at random from the set of successors is complete but extremely inefficient. ठीक है Now, what does it say? Therefore, it seems reasonable to try to combine hill climbing with a random walk in some way that yields both efficiency and completeness. So, simulated engineering is such algorithm. Okay, to explain simulated engineering, switch our point of view from hill climbing to gradient descent, that is minimizing the cost. Okay, so minimizing the cost and imagine the task of getting a ping pong ball into a deepest surface in a bumpy surface. You just like the ball on the rest at local minimum. If we shake the surface, we can bounce the ball out of the local minimum. The trick is to just shake hard enough and so on. Okay. तो सिमिलरिटी रनिंग में करंट में आपने मेक नोट किया for temperature 1 to infinity you pick the temperature if t equals to 0 then return the current next is a randomly selected successor of current delta e is next dot value minus
You
current.
actually have the old edition, I believe. In the
अच्छा
next in the new edition,
हाँ
the these next dot value and current dot value are swapped.
अच्छा and have the return if delta e less than 0 like.
Oh yeah, that's exactly. Let me share my screen. Like,
Sir, where can we get previous year's solution? Previous year assignment with solutions. So I have always discussed previous year solutions, assignment with solutions in the videos. But yeah, if you want a PDF, I will upload all of them like in the presentation folder.
can you
Ah.
see my
Yeah,
screen?
yeah, yeah. I can see your screen. Ah,
As you can see, like even though in your book it is said value next minus value current, in the latest edition global edition 4, the value of current minus next and delta is still they are taking as zero, greater than zero.
that means the next successor is worse.
This doesn't make sense because if if this is greater than zero, what it means is that the R value is
Mhm.
greater than the value of whatever the next we are choosing, right?
Mhm.
What when that happens, we actually apply this formula, not this formula.
Mhm.
Unless they should have written either cost here, or maybe this is a misprint in the new edition. I don't know.
The schedule input determines the value of the temperature. Anything was also yes in LSI. अच्छा ओके तो इसमें कैन यू स्क्रॉल अप वेयर इट इज डिस्कसिंग द सिमुलेटेड annealing like what does it is an algorithm अच्छा अच्छा नहीं टेक्स्ट तो एग्जैक्टली सेम है टेक्स्ट में तो देयर इज नो डिफरेंस if we just roll the ball gradient descent and so on if the value of the current is mm, And in the slides, and I think in this version of the book that I have, there it is clearly showing that.
Yeah, yeah. Your edition has the right exact same thing as the professor's slide,
Hmm.
but in the new edition, like they changed it. It's either a misprint now or it was a misprint then, and they corrected it, and now like since that was a misprint, then the professor may have taken it, or maybe this, I don't know.
So let me open the slides. I have read the slides for this version. What does the slide says? Let me just quickly roll it up.
Should I stop presenting?
Yeah, yeah, you can. It's fine. Hmm. Yeah, with that was I think live session uh, February 17th or February 10th maybe. Let's see. सिमुलेटेड एनीलिंग मतलब लोकल सर्च हाँ इसी में होगा ना हाँ इसी में होगा. So in simulated annealing here, the professor has said that value of next minus value of current and if delta is less. So this is inspired from the book only. Hmm.
This is inspired by the book of the previous edition. Yes.
Previous edition, yes. Hmm. It says, like lady, identify the quality of the local improvements instead of picking the best move. Pick one randomly. Say the change in objective function is delta. If delta is positive, then move to that state. Otherwise, move to this state with probability proportional to delta. Thus, worse moves are expected less often. However, there is always a chance of escaping from local maxima. Yeah, I, yeah, that might be just that there they might be taking value as cost or something. That might be a discrepancy there. But in my version, it is like saying that we are looking at the value of the state only. Make note a random value delta is next dot value current dot value, and the value is the value of the objective function that we are trying to optimize. So can you check what was the sign of this e to the power here? Was it still delta e or e to the power minus delta e?
Let me share it. It's literally just delta.
Anyways, I think that might just be a point of discrepancy, so we can just let it be like it's fine. But yeah, you can see my screen, right?
Yes.
Okay. Okay, so then we will start with this week's assignment. I hope that that might just be a discrepancy, that cost thing, and also can just maybe ignore it for the time being. I don't know. But yeah, in my version, it says only next dot value, current dot value, then delta I greater than zero. Now you take the probability with e to the power delta I by t. So But I would say that if such kind of questions comes in the exam, then just follow whatever was taught in the class. Like just follow the equations and the material that was discussed in the lecture. So at least if anything goes wrong or they do a mistake, then you can say that this is what was shown in the class and that is what we followed. So there is no.
No, I mean that didn't stop them from ruining my assignments, but
But in the assignments where we did the questions, right, in all of them we followed the same formula, right? E to the power
I'm
100.
not talking about numerical. That's happened. They marked many wrong, right? The Goal State one they marked wrong. Even here, I think the answers at least somewhere are controversial. They did that wrong. That numerical where there was like big table and we have to find probability of C given AB.
Probability of C given AB where?
Yeah, the assignment 10, I believe.
Acha, the one
Uh,
that we solved, but that was.
yeah, that was like they have like very bizarre way of solving that. Like they were just grounding it to 0 and 1 and like how?
Oh, so
No,
that was week 7,
next.
week
I think it's next.
week 9.
Week 9, week 9.
Week 10 तो बुरा वो था.
Yeah, this week. No, 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 below, go below. Yeah, this question, like they rounded it off to 1 and 0, right? And like they didn't give any good reason for rounding off point 0.8 to
हाँ वो
1.
तो.
Yeah,
Anyways, I just went by the observations and then I thought that.
yeah, yeah. Your observation is correct. Like there's certainly a trick to solve this in like one go.
Mhm.
Yeah, but
And
the
I was.
solution they share.
Yeah, yeah, I know that that was somewhat incorrect. And I was also thinking about this question that we solved last time, right? Where I solved by just calculating reward, and you actually did by that PAPC and calculating the probabilities. So you know what? It actually validated the statement that the professor was trying to make, that the answer ultimately that you will get by doing a model free learning or by doing a model based learning will ultimately be same, right?
Yeah,
you
yeah,
followed
definitely.
you followed that variation where you considered that I am transitioning from this state to that state, then you estimated the probabilities and then you got the value. But I just simply computed the reward in a r1 plus gamma, r2 plus gamma square, r3 kind of fashion and still got the same answer. So
No,
that.
I think no. If you do model-based learning, you will get a different answer here.
No, but you did model based, right? And you got.
No. I did not do that. I first thought of it that way, and then I corrected it.
No, but one of
You
the
will get a
students
different
last
answer
time.
if you do model-based learning.
No,
Like
no.
Nivadas did model-based learning, and I think she got it wrong.
No, no,
You will get
she got minus 0.125, right? Because she said that I did that and that's how I got minus 0.125, right?
no way that you are getting the same answer with model-based learning. I don't think.
Because if you check the slides, right? Like let me see if I have.
Yeah, the professor said that in that particular case, model-based and model-free learning will get the same answer, but I
No, no,
don't think.
not in that particular case actually. If you see, like let me just let me see whether I can get to there. Uh, mm, mm, yeah, model free, model based, and then there was this image. Yeah, this one. You see, so compute V star, Q star, pi star, evaluate a policy, VI, PI, and then this model free, Q learning, 3D learning, and so on. And then there was this one more slide where we showed the summation part.
Yeah, I know. The professor said like, I remember.
But I don't see that slide here. Like, where was that slide?
This was just after this slide he showed, but they removed it from the
No,
PPT.
no, no. I remember it because. Let's let me go to that example only. Na. EL, not model, model.
No, you do ahead. You won't find it now.
I
You
have
already did Q learning.
Q learning, yes. Yeah, that was just a good question. Like, uh, oh, slide ही पता नहीं कहाँ गया. Where did it go? Yeah, this one. It should be somewhere near, around this only. This slide, yeah, this one, yeah. So if you do model based, so you exactly did this, right? Reward into the
No, I didn't. I get my answer to model free.
yeah, you we followed this, but even if you follow this, you'll get the same answer, right?
I don't think so.
Because that's what it is saying, that without PA instead collect samples A1 to this. Why this works? Because eventually you learn the right model, and then what we did was that we just did sigma AI and then we took the average, whatever we saw. But anyways, I think that is something for you to check on your own. But that might be a good idea to do. Just a learning exercise you can have. Okay, so we will start with week 12 questions now. Quiz. Okay, so we have um, x1, x2, and x3. So let this be z1, z2, z3, and y. Okay, so when x1, x2, x3 are all zeros, what we will get? So z1 will be 0 plus 0, 0. So z1 will be 0, right? Because it is less than 0.5, will not trigger. This will be 0. So this will also be 0. 0, 0, z3 is 0. And for y also, we get 0. So when x1, x2, x3 is 0, y is 0, right? When x1, x2, x3 is 0, 0, 1, so this is 0 plus 0, so z1 is 0. 0 plus, it says x1, x3, x2. Okay, wow. This will not be 0 in that case. Huh. So x1, x3, and x2. So x2, x3. So x2 is 0, x3 is 1. So this will be 1. So z1 will be 1. x3 is 1. x1 is x1 is 0. x1 is 0, x3 is. Okay. So this will be 1 plus, so 2 into 1 plus 2 into 0. So that will be 2 and it is greater than 1. So we will get 1 here. 1 and 1, so 2, which is greater than 1.5. So we will get 1 here. And y is simply 1. So when it is 0, 0, 1, this is 1. Okay. And when it is 0, 1, 0, what do we get? So 0, so this is 1, this is 0, this is 0. So we will get 1 into 0, that is 1. So z1 will be 1, 0, 0, z2 will be 0, 1, 0, 1. So z3 will be 0 and y will be 0. So we get y as 0. Next, next we have uh, 0, 1, 1. So for x3 1 and x2 1, and this is 0. So z2 will be 1, x2, so this is 2, so this is greater than 0.51, and z3 will also be 1, so y will be 1, right? Were you all able to solve this question? Maybe some of you can just speak and let me know. Am I audible? Hello?
Yes.
Okay. So you were able to solve this question, right? I hope it was not that tough. Anyways, so when x2 is 0, x3 is 0, and x1 is 1, so we get z2 as 1, z1 as 0, and 1 plus 0 is 0, so y is 0. When we have 1, 0, 1, Acha, are we able to eliminate any of the options this far? Let me see. So x1 or x2 or x3. So that is, yeah, that is eliminated because when x1 is 1, y is 0. So that is not the answer. x1 implies not x2 implies x3, x1 implies x2 implies x3. Okay. Then I think it's better if we generate the entire truth table. Let's not hurry. Okay. So here we have z1 0, z2 0, z3 0, 0, 0, and 1. Yeah. So we have 1 0 1 is x1, x2, x3. So 1, 0, and 1. So this will be 1, this will be 1, this will be 1, and y will be 1, right? And for 1, 1, 0, 1 0 1 1 1 0, and 1 1 1. So 1, 2, 3, 4, 5, 6, 7. Yeah. So for 1 1 0, so for 1, this is 1, and this is 0. We get this as z2 as 1, z1 as 1, and z3 as 1, and y as 1, right? And for 1 1 1, we will also get this as 1. Okay. So x1 or x2 or x3 is out of the table because when x1 is 1, we don't see it. We don't see the we don't see the activation as 1. Okay. x1 to the power x2 to the power x3. Okay. Or it is x1 XOR x2 XOR x3. What is that? How did you guys interpret this last option?
That's obviously x1 intersection x2 intersection x3.
Acha, that is an and. Oh, okay.
Yeah, they don't like they have like no.
In C, if you write like this, that means it is XOR.
Yeah, I know, right? I know. In
I was
Python
I
it's
was
different,
I
in
was
C it's
totally
different.
going to plant it as XOR. My God, these people. Wow. Yeah, so it is also not an and because when x1 is 1, x2 is 1, and x3 is 0, it is still 1. So, and even when x1 is 0, it is 1, so it is not an and. So that brings us to the last. These two options, x1 implies not x2 implies x3. Okay. So x1 implies not x2 implies x3. So what will be the final expression for this? It will be not of x1 or x2 implies x3, and that will be x1 and not of x2 or x3. Okay. So when it is 0 0 0, so this is 0 and 1 or 0, so this is 0. Okay. When it is 0 0 1, so 0, so this will be 0, this will be 1, so it will be 1. When it is 0 1 0, when it is 0 1 0 1 0, it is 0, that is true. When it is 0 1 1, 0 1 1, it is 1, that is correct. When it is 1 0 0, so this part will be 1. So when it is 1 0 0. Oh, did we do this wrong? I don't know. 1 mm, 1 0 0. हाँ या 1 0 0 पे ये 1 होगा. Sorry. Alright. Hmm. Yeah, when it is x1 is 1, x2 is 0, x3 नहीं यार. uh, x1 is 1, x2 is 0, x3 is 0. So this will be 0. What did I do wrong? Let me just solve this again.
So like there's a very easy way to I think it trick to solve it. If you think about it, x1 and x3 are symmetrical to x3 and x1 and x2 are symmetrical to x2 and x3
Mm-hmm.
because both of them are going to the same gate,
Mm-hmm.
right? So any answer we get must be like symmetrical for x1 and x3, right? And if you
Any
do that,
answer?
we can eliminate option number one and option number three. Remaining are option number two and option number four. Option number four is obviously wrong. Just you can hit and try like
हाँ
and so
वो
the
जीरो
yeah
जीरो
option
वन करके वन आ गया सो या दैट इज रॉन्ग.
yeah. So the only answer is option number two
Why not option number 3? Can you elaborate on that?
because option number three is not symmetrical. X1 implies x2. Can you like show the option number three?
हाँ x1 implies x2 implies x3.
Yeah, so x1 implies x2 is not symmetric. X1 implies x2 implies x3 is not symmetrical.
अच्छा it is not
If you
x1.
swap x1 and x3, the answer does not become the same thing.
No, I'm not getting your point. So symmetrical से what do you mean symmetrical?
What
Can
do
you
I
give more
mean by
context?
that? If you look at x1 and x2, I
हाँ
sorry, can you show the question?
हाँ हाँ हाँ, sure.
So if you scroll up a little bit, if you look at x1 and x3,
Hmm.
these both form actually simply AND gate, right? If x1 is true and x3 is true, only no if they form a OR gate, sorry, if x1 either when x1 or x3 is true, the signal gets passed down,
हाँ हाँ,
right.
sure.
Same thing is between x2 and x3. If either
Same
one of
thing
us
with
is
x2
true, then the
x3.
signal gets passed down,
हाँ हाँ,
right.
ठीक.
So you can just remove all this thing and just make an OR gate there. You will find that because and if you look further from this, this is also symmetrical, right? The value of the threshold does not matter. This is just an OR gate, and this is OR gate. So I'm saying like x1 and x2
No,
are
this is an
symmetrical.
AND gate, right? Because
Yeah,
it
yeah.
is
The
storing
furthermore,
only.
it's an AND gate, but this previous is OR gate, right?
Previous two is OR gate, and this triangle 0.5, 1,
Yeah,
1.5,
yeah. This is
this
AND
looks like
gate.
an AND gate.
This is an AND gate.
Hmm.
Yeah. But I'm saying like the node value does not matter, right? It's symmetrical from here on out.
हाँ ठीक है, that argument
Right.
I
X1 and X2, if in the answer you swap X1 and X2, the answer should not be different. You get my point? If you swap X1 and X2 in the answer, it should
mm-hmm,
not make it should not give you a different answer.
mm-hmm.
That is only possible in option number one, option number two, and option number four.
Option number 1, option number 2, and option number
Because
3.
if you swap X1 and X2, it gives you the same thing.
अच्छा हाँ ठीक है, x1 और x2 और x3.
That is not
X1
true for
implies
option
not
number three.
x2 or x3, and x1 and x2 or x3. So if we swap x2 or x1, so this will be not of x2 or not of x1, not of x1, not of x2. अच्छा हाँ ठीक है ना. So this entire thing will become x1 and x2 or x3. Yeah,
Exactly.
I missed a negation there. That's why my calculations were going all south. हाँ, ठीक है ना. So it is x1 and x2 or x3. Hmm. ठीक है. So x1 and x2. अच्छा, but when x1, x2, x3. Okay, so when x1 is 1, x2 is 0, x3 is 0. So this will be 0, right? Z1 will be 0.
Yeah, Z1, X1, yeah, this will be zero, and below it will be true. But they
Below,
both give zero actually. So the answer will be zero.
the answer will be 0, right? So that's why this x1 or x2 or x3 is not x1 or x2 or x3 is anyways not correct. X1 and x2 and x3 is also not correct. X1 and x2 or x3. So x1 and x2. Here it is 0 0 0 0, and when it is 1, it is 1 0 0. So this is 1, that's why it is 1. That's and what if we do? I'm just doing it for the sake of completeness, right? I hope you understand that. Not x1 or x2. Then we do a negation or x3. That is the second thing, right? Because it says x1 implies x2 implies x3. That is what it says. So this will ultimately look like this. So this will be x1 and not x2 or x3. So let me just quickly go over the values. So for 0 0 0 it is 0. For 0 0 and 1 it is 1. For 0 1 0 it is 0. For 0 1 1 it is 1. For 1 0 0 it is 0. So yeah, this gets false when it is 1 0 0. And for what about the rest? 1 0 1 1 0 1 it is 1. 1 1 0 it is 1, which is also not correct. And for 1 1 1 it is 1, that is fine. Okay. So yeah, this entire thing maps to x1 and x2 or x3, which is coming from x1 and not x2 implies x3. So yeah, that option is correct. On the second one, which of the following are correct regarding the various non-linear activation functions? For sigmoid activation, strongest signal will flow to the weights of a neuron when activation is near 0 or 1. Is it true? Would anyone like to?
It will explain in the no, it's false.
Hmm. 10H is a scale transformation of sigmoid version. Is there any question?
Yeah, somebody is saying that option number one is true.
No, acha. Hmm. We should get bonus marks for it. I am not the right person to discuss such things. But you can unmute yourself and speak. Like you don't need to stay mute. Like it's fine. We are just how many 8 people, so you don't need to worry. You can just unmute and speak.
Option number one were actually explained in the class, saying that because the derivative of sigmoid is actually very small at the near zero and near one, so the signal strength is actually very small as well.
Acha, it is not saying the strongest signal will flow to the output of the next layer or something like that.
No, it is saying that strong when is the you see the signal is proportional to the differentiation of the function, right? Activation function.
Signal
And
will
the
flow to
sigmoid is
the
actually very the differentiation of
ah,
sigmoid is very small
so
near 0 and 1.
1 के करीब तो it becomes 0 because I remember the shape of sigmoid is like this, right? If I'm not,
S curve.
it's like this, something like this.
Yeah, yeah. If you like look
Achha,
at
this
near,
is actually sorry. This is 10H. Sigmoid is like this, or
yeah, if
the
you
other
look
way around, like. Hmm.
if you look at like very close to 1, the
Ah,
differentiation of sigmoid
right.
is 0. So
This
no
one.
signal flows through. And if you look at 0, the differentiation of sigmoid is also 0.
हाँ यहाँ पे तो कुछ है ही
No,
नहीं.
no, not that, not that, below that. Yeah,
अच्छा,
yeah,
yeah, this one. हाँ.
yeah. The differentiation, so that's why the signal strength is also 0 there.
अच्छा, it
So
is
the option number
highest.
one is
हाँ. So this is when you are somewhere in this region, it works. Otherwise, it does not. Just signal flows at the time of back propagation. That's what the statement is saying, or that's what how it was explained in the class. What does this
no,
statement
yeah,
mean?
back propagation. Like when we try to when back propagation, we differentiate the function, right?
हाँ, वही ना.
Yeah.
But sigma have
So it's
strongest
the
signal will
opposite is
flow to
true.
the
It should
weight
be
of
the
the neuron.
weakest actually. Weakest signal will flow weight of the neuron where activation is near 0 and 1.
And 10h looks like a scale. Relativation can output a larger range of value than sigmoid. That is obviously
Option
true.
number two, I think, sir, they got it wrong. Option number two is false actually.
So let me
10s
just.
is actually a scaled and shifted transform.
Oh, is man at this guy? But 10h is. It is shifted because it is minus 1,
Yeah,
right?
it is shifted, right? Because of the minus one.
Hmm.
So the option number B should be wrong. It is scaled and shifted. And the option only says scaled. So I don't like it.
Hmm.
But then I got deducted zero point 0.4 per marks for that.
Uh, a sigmoid is 1 over 1 plus e to the power x, right?
Yes.
Ah, so now it's equation, so it is there only like 10h of x is 2 sigma 2x minus 1 e to the power x upon 1 plus 1 upon 1 plus e to the power minus x, and 10h is e to the power x minus e to the power minus x divided by e to the power x plus e to the power minus x. So e to the power minus x, so 2 e to the power 2 e to the power 2x minus 1. ठीक है, 2 sigma 2x. It is scaled because it is sigma 2x also, and it is multiplied twice and shifted by 1. Are these people? I have no control on these kind of problems, to be frank. You should ask to the people who actually upload these solutions, like what you guys are doing, because I think they just wrote that refer to the lecture, right? They have uploaded week 12 solutions. I checked it. I don't want to open it right now. I think in this file they have said that it is just refer to the lecture or something. They don't even mention that which slide or refer lecture content for other options. Refer lecture networks, refer lecture content, refer lecture content. Uh, but yeah, I agree with you. It is a scale and but it is minus one to plus one, right? How? Why are you claiming it as shifted? Let me just think. Why are you claiming it as shifted?
So the when we do addition or subtraction, we say that the function is shifted, right? If you add or subtract from any function, you say that the function is shifted.
But see, let me just go over think about it. So your sigmoid looks like this, right? This is your sigmoid. If I'm not wrong,
No, you're right.
right? And your tan h just looks like this.
Yes.
So where it is, acha, it is shifted but down, yeah.
Yeah, like if you scale it, the range will be go from 0 to 2, right? And then you shift it by negative 1. You scale it by twice, and then you push
Hmm.
it down.
Now what that I understood that
So like
from
it is
0 to
scaled
1
and
you are
shifted.
going minus 1 to minus 1 to plus 1. So hmm, yes, there is a shift which they should have mentioned. Do the professor talk about this in the lecture? Like, is it a
No,
scale?
I don't think so. It is like glossed over very quickly.
And the rest two options are just
They are previous.
pretty
There's
much
nothing special.
straightforward. Like Relu is just max of 0 comma x, and yeah, can accelerate the convergence of SGD. And this type of question we already solved last in the Dow. But yeah, you maybe Is there a way to challenge or ask? Like, I don't know about this thing actually, because I am not the TA per se about this course. That's the problem.
So this week has the many problems in it. Especially the multiple select ones. If we select any of the options, then it is marked wrong.
I said they
We
have
don't get
negative
a,
marking also this time.
yeah, no, it is
No, there is no
straightly
negative marking.
not negative marking, but if we won't select even a single one, then also it is incorrect, right? Will score will be zero. So we are scoring very less in this, especially this one. I've done many of the courses in past, but since this is my last time I'm doing this course, I'm getting very less marks.
Acha, it's not part. There is no partial marking. If you select all the options, then only
Ah,
it's telling you
yes,
that.
sir, that's problem. And
But
in some week there are only this multiple select option only.
this
There are
week I
many
see
in this.
all the questions are the theory. At least the textual ones are all multiple
And
marking.
they're not very clear, no? So how can we mark so accurately?
Okay. Anyways, so we can just
Sir,
convert.
you are there only for solving purpose.
Huh?
That challenge. How can we question or challenge a particular question?
I have no idea. I have no
Can
idea.
we mail it or there is some process?
I have literally I have no idea, about this thing because I have never done an NPTEL course myself, so I don't
I
know.
have done in past a few many courses, sir, and this is the last course of my last. I'm doing a minors, so this is the last one. But I this time I missed a few of courses, and then when I started solving it, I'm getting so less marks that I've missed it by two marks. Two questions. If I would have marked right, then I would have qualified for this week. And also, I've applied for this exam also. So I
Hmm.
don't know what to do. I appear for exam or not? And if I appear, then also how
Yeah, I think this kind of problems maybe you can take up with the management or some maybe the NPTEL team itself because I have no jurisdiction there. Like I don't even know the problems to tell you the like appropriate point of contact or solution in that aspect. Like
so we should call on a helpline. Is there some helpline or something?
I have no idea. I have legit no idea.
So we have two lectures today, no? So this is the one, and the other starts from 7 or 8, right?
It's a 7 to 9.
7 to 9, yeah.
79. That is also a doubt solving or something
No,
else?
it's the same thing, just a different year.
Same thing.
Anyways, this week we don't have that much content also to discuss because this was the last assignment and this was kind of like a wind up session. Okay, we will just solve and because I was looking for maybe possible question papers, but I did not find any to help you with the exams or
So
something.
you don't have contact of the professor who teaches us.
No, no. I
So
have
you are hired something to solve doubts, right?
so
Something like
actually
that.
the thing is that the professor is from IIT Delhi, the one who is
Oh,
teaching the course, and even he's not taking live classes per se. These are video that was recorded in 2018, and they have been like replaying or rerunning that content for the past 2 or 3 runs, right?
okay.
So we like I am doing this as a part of my curriculum, like so there is this prime minister research fellow program for PhD
Oh,
students
okay.
that are from any of the government funded institutes like IITs, NITs, and maybe state level colleges. So as part of that program, we are required to do 50 hours of teaching duty.
yes, yes.
So for this semester, I took AI in NPTEL to complete that 25 hours quota for this semester. So that's why it is like this.
So you can't help us in any way
So I
in
can
this
help you with
management.
questions about the course, but like these kind of administrative things, I have no idea. Like what is the channel or who to talk or that kind of things. I have no idea. Yeah. Yes, we have not even sat once with Professor Mosam to discuss like what will be the course layout or what is our teaching role. It is just that the PMRF authority told us that you have to do this course and we are just doing this course. So it's just like that. Maybe you can
Sir,
mail to the authorities that is sending you the mail. Like how are you getting the mails of this class? Like
Yeah, those are just automated mails, no reply.
ऑटोमेटेड या ऑल्सो सर एक अभी यहाँ पे एक बोनस आया था कौन से वीक के मेल आया था हमको कि कौन से वीक का एक सोल्यूशन आंसर चेंज किए तो
हाँ,
Yeah.
वो किसने किया वो
oh, week
मतलब
number 10 में they just updated the range. I was telling na that there are some range issues in some of the questions, right? तो
तो वो
उन्होंने
लोग ने अपने आप से किया कि किसी ने कंप्लेंट किया रहेगा फिर
वो हो गया होगा पता नहीं वो टीए बीए को चमका होगा कुछ तो उसने बस रेंज बढ़ा के उसको 2.16 से 2.48 कर दिया एंड
बताओ हमारा नहीं सुनेगी
वो पता नहीं मुझे मैं आई एम नॉट मैंने किसी को कुछ बोला भी नहीं है मेरा तो कम्युनिकेशन भी नहीं होता बोलता रहा हूँ ना मैं मेरी किसी से बात भी नहीं होती इस मामले में मैं तो तुम लोगों के सामने आता हूँ सॉल्व करता हूँ और चला जाता हूँ बस इतना ही रूल है मेरा इस कोर्स से और कोई वास्ता भी नहीं है ना प्रोफेसर से बात होती है ना किसी दूसरे टीए से बात होती है जो भी ये कोर्स ले रहा है बस वही है इसलिए शायद आप लोगों को ओवरलैपिंग भी लगता होगा कि ये चीज़ यहाँ पे डिस्कस हो रही है वही चीज़ वहाँ पे डिस्कस हो रही है ये क्या हो रहा है मतलब बट या दैट्स हाउ इट इज I was thinking that maybe they updated this answer that reward is not like discount factor is not useful, but somehow they did not change this. Like they updated this range, which was not even needed because it was like an absolute answer. Because I remember solving this question. It was exactly 2.48. There was not even like 2.467 or something going on. It was just 2.48, like no other value. Hmm. Anyways, so yeah, resuming back to the yeah. So you're on this question that assume that an input image of say 64 by 64 is passed through convolution filter of say 6 by 6 and stride 2, right? So it is given that the input image is of size 64, the size of filter is 6 and the stride is 2. So 64 and size of filter is 6 and the stride is 2. So it will be 64 minus 6 divided by 2 plus 1. So that is 32 minus 3. 32 minus 3 plus 1. So 32 minus 2, right? 60. And that is 30. Is my calculation correct? 58, 29 plus 130. Huh? Then after that, after passing to 30, it is of it is max pooling filter of size 2 by 2 and stride 2. Okay. So when we are passing through, so when we are passing through a pooling layer, right? So it will just if it is of size k, in pooling layer we only consider the stride value. So it will be 30 divided by 2, which is simply 15, right? Because there are no multiplication or anything. We just apply the filter and get the size and get the output of the image. So if it is a max pooling filter of size 2 by 2 and a stride 2, so it will be just 30 divided by 2, 15. हाँ, ये हुआ ना. As long as neural network has at least one hidden layer and sufficient number of parameters, it can represent any continuous function to arbitrary accuracy. I think this might be discussed in the class, these kind of things.
Yeah, four of them are discussed in the class.
Achha. So fat and short networks made better use of compositionality of classification task as compared to the tall and thin networks, and fat and short networks may struggle more when some of the design output classes are underrepresented. And why would this be the case? Like, can any one of you reiterate what was taught about these things? You guys are going through the course material, right? I mean, I hope you guys are indeed, because otherwise it's not helpful that much. So as long as a neural network has at least one hidden layer, so that point is true. If we are given a fixed number of parameters, the optimal network in terms of learnability will have one neuron per hidden layer and number of parameters. So I have no idea how to even interpret this statement. Like, what optimal network in terms of learnability will have one neuron per hidden layer. Huh? But why would you make such a network? Like, it does not make any sense. So
Yeah, that's just a dumb,
yeah,
the
it's
intentionally
a
dumb
dumb
one.
statement, right? But
Yeah,
and you might even face the issue of like maybe this will lead to like vanishing gradient problem, right? Because if you have that many hidden layers, the the down layers won't even receive any gradients. I don't know, like, why have they even asked such kind of, that is obviously not correct. So fat and short networks make better use of compositionality of the classification task as compared to tall and thin networks. So was
No,
any
that's
such
not
concept
true. That's
discussed?
not true. Pattern short networks. This is the, I mean, statement kind. Compositional thing is present only in deep and tall and deep network. And the last option is true because
अच्छा, this
for a training
compositionality
data.
of classification tasks है वही the thing that we were discussing last time, right? That
Yes, yes.
we will learn
yeah,
with the
exactly.
numbers.
That 10H and sigmoid thing. Yeah,
Okay, okay, now I get it. And fat and short network may struggle more when some of the desired output classes are underrepresented.
yeah. This is explained directly in the
हाँ, क्योंकि वही ना, क्योंकि
lecture.
उसके बारे में लर्न नहीं कर पाएगा एब्स्ट्रैक्ट फीचर्स, तो will not be optimal. सही है. Which of the following is correct regarding the issues faced by AI systems? अच्छा. The robustness issue discussed in the class characterizes the tendency of the system to give completely incorrect output when tiny adversarial perturbations are applied to the weights of the network.
Oh, yeah, that's why it's wrong.
Yeah, that's what
It's
is
not
wrong.
the weights, it's the input.
That's the mistake. That is the mistake.
Achha. The transparency issue discussed in the class characterizes the opaqueness of a system regarding why a particular network configuration fails or succeeds at a particular task. ठीक है,
That is true.
bias issue discussed in class characterizes a tendency to amplify racial or gender bias present in the training data. ठीक है, वो तो मतलब आप ए बोल के यही एक्सप्लेन कर रहे हो, तो ये स्टेटमेंट amplifies racial or gender bias. But this is just an example system. ठीक है.
No, no. In the
Privacy issue.
example, I mean, they are given an example where this gender bias was, I mean, it
हाँ,
was
वो तो
evident from
समझ गया.
this, but well, then that's the bias thing.
And that's what I'm saying. That is, it is a specific example scenario. Like, it can be any bias present in the training data. It need not necessarily be just racial or gender bias. So
Yeah, exactly. Yeah.
this we discuss in the class. So that's why I'm fine with whatever they have written after that. Like, this is like, have they discussed about federated learning concepts also? Like, have they gone in that much depth?
What is it?
Like federated learning or like
No,
this
no, no, no.
privacy issue? Like, Because if they have discussed the issue, then they might have also discussed the how to mitigate these issues, right? Or they only
Now, the
discuss the issue.
ethical issues they had discussed, AI and ethics. Under that, I think they have given all this.
Yeah, it was like a very one presentation, like half an hour slide for everything. They didn't go in detail or discuss the ethics, just stated it.
Uh, ठीक है. Consider one layer of a neural network, the weight and bias matrix as this, and x is this. So what is the value of y? तो नेगेटिव वाले तो पहले ही हटा दो, तो ये दोनों बच्चे में पहली रो कंप्यूट करनी है, बस खत्म. तो पहली रो हो जाएगी 416, 0.4 प्लस
Yeah,
170.
this is simple.
हाँ.
WXB, I mean, ReLU of WX plus B.
So that's what I was saying, right? Like
Yeah.
option A and C are anyways gone. So we just need to compute the first row to validate which of the option B or D is correct. So that I was just doing that. So 0.4, 4 fours are 16, and 0.1, 0.1, 0.17, and
That's the correct answer. 0.17.
0.17. वही हो गया. तो what are these guys even planning to do? Wow. Then it is which of the following are correct for CNNs? Convolutional neural network consists of hand-designed convolutional filters along with fully connected neural network layers. hand designed तो नहीं होते.
No, they are not hand designed. They are parameterized and let the neural network learn them.
Hmm.
Nothing is hand designed. We only give the
The
structure
architecture is hand
of the
designed.
Architecture is hand
architecture.
designed. I was about to come to that. Like the weight of the filters is learned, but the dimension of the filters is something that you have to give yourself. Like
Yeah, yeah.
the output of the CNN is invariant to minor transitional shifts in input.
Yeah, that's true. Explained in the class.
Transitional shift, but it says transitional shifts in input, right? So, but the robustness issue will then be a problem, right?
What do you mean robustness?
It says minor. Acha, what does transitional shift means first? Like, let.
Transition shift means like moving every weight, every pixel to the right or left or up or down.
Acha, so it's not like add. Acha, ठीक है.
No,
Translation.
no, sir. It's like handwritten numeral recognition. You see, one can write in any way, na? Slanted. I mean, when you are writing one, it
Yeah,
can be
like
straight
it
or
doesn't
it
matter.
can be slanted. So that's, I mean, even if that's slanted, then it should be identified as one kind of thing.
No, but acha, minor is the keyword. Like, if it just says invariant to translational shift,
No, it's
Yeah,
minor.
that would be
This is
false. That
minor.
would be
Yes,
false.
minor is.
the first major success of deep learning was based on performance CNN on the ImageNet task. Okay, you know the name of the architecture, right? This should have been discussed in.
AlexNet, na? That's AlexNet, I think,
Uh,
in 2012.
yes, yes, yes. Alex. The layer before softmax or sigmoid in CNN for image recognition is usually a fully connected neural. Because you flatten and then you give कि भैया दे. ठीक है. That's true. Now, which of the following is the reason for employing replay buffers in? ये तो ठीक है. Sparsity in rewards during. So I think this would have been like totally discussed in the class. Extremely large state space, extremely large action space, implying replay offers the violation of IID assumption between consecutive samples of an episode. And sparsity in rewards in the episode. Ah. Ah. If g of z is a sigmoid function, what is the correct expression for its derivative? That's a good question. But I think you guys already know that. Like, so let me just see. And yeah, Do you want me to solve this one? I mean, it's fine. I can just quickly go over that. It's a very. I hope it would not be that painstaking, and I have not done a calculus in a very long time. So yeah,
It's pretty straightforward.
yeah. So sigmoid is 1 over 1 plus e to the power minus x, or we can also write it as e to the power x over 1 plus e to the power x, right? So this will be 1 power x plus 1 minus 1. So 1 minus 1 over 1 plus e to the power x, right? ठीक है, देखते हैं तो अगर y डैश करूँगा, so this will be 1 plus e to the power x the whole squared into 1 plus e to the power x the differentiation of minus 1, that is 0, and minus 1 into differentiation of minus 1, that is e to the power x. So this is e to the power x over 1 plus e to the power x the whole square. Okay, so e to the power x plus 1 minus 1. So 1 over 1 plus e to the power x minus 1 over 1 plus e to the power x the whole square. Am I going anywhere with this? I don't know. As I said, is 1 y into what's 1 plus e to the power x the whole square e to the power x.
Sir, it is 1 plus e to the power minus x whole square, na? This is plus x.
नहीं नहीं नहीं, वो तो मैंने फिर उसको कर दिया ना एक्सपांड, 1 माइनस 1 ओवर ए टू 1 प्लस ई टू द पावर एक्स द होल स्क्वायर हो गया. तो दिस इज ई टू द पावर एक्स प्लस 1. हाँ, अच्छा, इसको यहीं से ले जाने दो आगे. सो ई टू द पावर एक्स ठीक है. तो so what we have is, so this will be y times, this will be y times 1 over 1 plus e to the power x, ठीक है, and 1 plus 1 over e to the power x, 1 plus 1 over e to the power x, this is 1 minus y. So that's how we get y times 1 minus y. ठीक. You understood the calculation, right? So it just follows like so. See, what we have, I'll just reiterate. So after differentiation, we got e to the power x over 1 plus e to the power x the whole squared, right? So e to the power x over 1 plus e to the power x, that is y, right? That is this value of that is the sigmoid function, and then we have a 1 over 1 plus e to the power x. So I just wrote it 1 over 1 plus e to the power x as 1 minus y from this equation. So y is 1 minus 1 over 1 plus e to the power x, and so this will give us 1 plus e to the power x is 1 minus y. So it is g of z into 1 minus g of z. So yeah, that's how we get it. And the final question, it is tan h of x, and we already saw last time that tan h of x is g of z into 1 minus gz the whole square. So it was 2y into the derivative of y, which is del j by del b. So del j by del b will be del j by del y into del y by del z. What it would be? Let me see. Yeah, del j by del y, and then del y by del z, and del z by del b. That's how we will write it. Into del z by del b. So del z by del b is just 1. Del y by del z is uh, it is, so since the y is tan h of x, tan h of x, this will be y into 1 minus y squared, and that's what we have written here. So it is 2 of y minus 1 minus y squared, and del h of So and del j by del y will be just 2y. So it will be 2y into 1 minus y squared. Something so on. Okay, so yeah, with that we can, like, we have come to an end. If there are any questions or anything related to the codes, not the administrative part, I will just clarify that. So yeah, we
Sir,
can.
from on informed search strategies, can you
Mhm.
discuss some problems or give me the link so that I can do some problem, like
I
where
know.
DFS, BFS, and all other things are discussed clearly? I have problems in that.
Acha, acha,
One
there are,
problem, if you take and then solve it using all strategies like DFS,
देख लेते हैं ना यहाँ पे कुछ तो होगा
yeah,
जैसे
depth limited and iterative deepening, then it will be clear. Clear.
okay, so let me find an easier graph then. This is like a huge graph. अच्छा, okay, let's just do this.
Yeah, this you can take, sir.
तो क्या है, ए से जे तक जाना है और मुझे लगाना है यूनिफॉर्म कॉस्ट सर्च. So consider the following graph with start state A and goes. Assume that edges between the nodes have cost equal to the absolute difference of the position of the corresponding. Why such cost of the edges between state F and J is 4F, and assume all edges are bidirectional and ties are broken lexicographically. Oh, so set is always lexicographically the whole set is here. ठीक है वैसे, like this is fine. So वैसे में यूनिफॉर्म कॉस्ट सर्च सब मतलब आपको क्या चाहिए, बीएफएस डी, सो यू वांट मी टू गो थ्रू ऑल द.
No, no, all this on informed search, how do you do? I just want to see how you solve this
आई नॉर्मली लाइक सो.
BFS, BFS, and all, so that I can get and iterative deepening. All these four strategies are there under I think on in search. Just to
सी.
solve one problem, so how they maintain the queue at the node and all. Just I just want to see that,
हाँ, या
go through that.
जस्ट
That's
लेट
it.
मी.
Otherwise, give me links so that I can go through it.
Actually, I think there is some audio issues in those initial lectures. So let
Yeah,
me just see Jamboard. See, for BFS and DFS, so we just maintain, like, for BFS we maintain a queue, and for DFS we maintain a stack. It is a standard thing. ठीक है, तो यहाँ पे एज वेट्स
that
गिवन है.
completeness issues and other thing. There I have.
You also want that. Let me
No,
then
no,
just
no. Anyway, all things related to that.
let me just, so I have, we have like slides. So let me just see. So that would be Feb 3rd or Feb 10th. I think it would be Feb 10th. In the second week, na? No, no, it will be week. It will be Feb 3 only. And so let me then just
I think it's in week two,
February
week
3.
two,
Like I think that would be
yeah,
the first
week two,
lecture.
week two.
For Feb after live session February 3. What? And so I changed the titles right now. What is the state? And if you want like an example of DFS, so okay, I'll just solve DFS.
Same
So
example and solve which can be
so let's
solved
say you
using
want to
BFS,
go
BFS.
from, let's say you want to go from A to L. Okay, let's say you want to go from A to L. Huh? And if we are applying breadth first search, okay, if we are applying breadth first search, how will the states, how will the queue look like? So we will first put A into the queue. Okay, so this is how the queue will look like. We'll first put A, right? Then we will pop A, right? Then we will pop A, then we will put the successors of A. So that is B, C, and D. So let's say we follow lexicographically smaller order. So the one which is lexicographically smaller, that is that comes close to A, then to Z. We will keep that in the queue first. Okay. So that is how we will do it. So that the order will be B, C, and D, right? Then we will pop B, right? What are the neighbors of B, E, and F? So the queue will progress like C, D. Then we will add E and F. Okay. Then we will do C. So A is explored, B is explored, C is explored, right? What are the children of C? They are children of C is G and F. A, C, D, F and G. Sorry, not G and F. And F is already in the queue, right? So we will just put D, E, F, and
I
G.
think you need to put F twice. If the F is explored twice, you have to put twice because in the answer, many letters are given multiple times.
Anyways, I'm just giving like an example. Like that's how the queue will progress. So you got the idea, right? Like since so we will just put this in a queue. So it will be first in, first out. Yeah. Do you know the concepts of stacks and queues like first in, first out, last in, first out, and things like that?
Yeah, sir, I'm just going to hop off and I just want to say like thank you very much.
Ah, it's
Yeah,
fine.
yeah, I'm just going to hop off. Yeah,
Ah,
see
it's
you.
fine.
Yeah, maybe some.
Yeah. Okay. Yeah, so this is how the BFS will progress. So we will then explore D, right? And then we will put the neighbors of D into the queue, which is G and H. So this will be E, F, and G is already there in the queue, and then we will put H, right? Then we will pick up E. So BFS, if you see the pattern, we are going layer wise, that we are exploring the children's in a layered fashion, right? So ones that are at one hop distance from the goal, from the start state, then we explore next that are at two hop distance from the start state, then we explore ones that are at the three hop distance from the start state, and finally we reach the goal state, that is L, right? So this was our standard BFS procedure. Okay. Now let me show you how DFS works. Okay. So in DFS, the key idea is that we, so let me clear frame. Clear frame. The control. You're still there, right? I hope you are still there.
Yes, yes, I'm there.
You're able to follow, right? I mean, I
Yeah.
hope I'm not going too fast.
Yes, yes.
So that was simple BFS. When then we do DFS, right? In DFS, what we do? In DFS, we do the depth first order, right? So here we have a stack. Okay? We take the stack, right? Then we pop A, right? Then we pop A and add the children's. So the one that we want to explore next, that will go at the last. That is what you have to ensure, right? So since we are following lexicographically smaller order, the stack will look like D, C, and B. Then we will pop B, right? So A is done, B is done. Then the children of B are E and F, right? So then we'll put E and F. But at the time of insertion, we will ensure that E is at the top because that is what we will explore next, right? So then we will take E, right? So then we will pop E. So the child of E is just I. So we'll replace E with I. Then we will pop I, explore I. The child of I is L. So we reach the goal state, right? So you can see clearly that in like for this example, if we just apply DFS, we would reach the goal state much faster.
Yes, sir. But what is the order of traversal? I mean,
So the order of traversal would be A,
hmm,
then A to B, B to
yeah,
E, E to I, and then
huh?
finally I to L.
I to L. Okay.
That is the order of traversal. Whereas for BFS it will be A,
Hmm.
then B, then C, then D,
D. Hmm.
right?
Hmm.
Then we will start exploring with E, then F. I mean, it is not exactly the order of traversal, but it would be the order of visit, like order of the nodes that we have visited,
Hmm.
right?
EFGH.
Uh, So it will let me just clarify this. So in BFS, you will get the order in which you are exploring the nodes, right? So essentially, we are maintaining the order in which you explore the nodes, not exactly the path per se. However, in case of DFS, it looks so, but it might not be the case always. So it is A B E I L, right? And
Hmm.
then so this was the DFS exploration, right?
Right.
And for BFS, we have A, then we will do B C D, then we will do E F G and H, then we will do I J and K, and then finally we will do L. This will be the order of exploration,
Hmm.
right?
Okay.
Now,
Hmm.
this is clear.
Yeah. Order of traversal is clear.
This is so order of traversal is like you just
No,
back.
but in DFS, sir, you have to backtrack, no?
We
So
so
when you backtrack, that will not appear in the order of traversal.
no, I'm not even talking about order of traversal, right? I'm just
Okay.
talking about the order in which you have visited the nodes.
Visited the nodes, right?
Order of traversal, so you have to do backtracking. So for that, we have to maintain a separate queue or like a separate data structure in which you are visiting that who is the parent of this node or how
Hmm.
I have come to this node, and then you do backtracking like from L, how did I come to L? So I came through I. So how did I come to I? I came through E. How did I
No, but
came through E?
order of traversal doesn't take into account this backtracking. The nodes
What,
that you backtrack,
what,
that will be repeated. No? I mean, the parent node might be repeated so many times.
so
So
what
they
happens
will
in
not appear in
DFS?
that
And what happens
order of
in what happens in DFS is you also maintain a parent-child structure, right? So essentially, whenever you visit a state, you
hmm.
also store how did you reach to this state, right?
Okay, then the parent of this, that means.
So basically, the parent of that child. So in
Hmm.
that sense, you backtrack. Like, so how did you come to L? Okay, I came through I. How did you reach to I? Okay, I came through E. How did I came to E? I came through B. How did I came to B? I came to A. And then you just print this path. Okay, so this is the path.
Okay.
That is the order of traversal. But what I
Hmm.
have written here is the order of exploration. It is not the order of
Exploration. Okay.
traversal. Just like I just want to point out that clarification.
Hmm. Order of exploration means the order in which nodes have been visited.
Order in which
Nodes
nodes
are
are
visited.
yeah, order in which nodes are visited. Yeah,
Hmm.
order in which nodes are visited. That is the order of exploration.
Hmm.
So since here I considered that we are doing a duplicate check.
Hmm.
That's why we have A B C D E F G H I J K L,
Okay.
right? But in case we are not doing duplicated checks, so we will also maintain the order in which we are visiting. Like if say if F is already in the queue, we'll also add F in the queue, right? That is what we will do. So in the question, you have to identify what the question is asking. So here it is saying breadth first search with no duplicate checking, right?
Hmm. Hmm.
So that means then let me just show you
That
how.
means it may appear twice.
So let me just
One.
show
Okay.
how the queue will look like, right? Let
Hmm.
me just show you the queue. Okay? Then it will make things more clear.
Hmm.
So what we have here is I don't know it is working or not. Hmm. Okay. So we will start with obviously with A in the queue, right? So this is our queue. We'll start with A in the queue. Then we pop A. A is
Hmm.
visited. So order of exploration I am writing at the bottom. So okay, we started with A, right? Then we put B followed by C followed by D, right? That is what we have in the queue so far. Then we pop B, order of exploration A B. Then we have C and D in the queue and the children of B, that is E and F. Okay, good. Then we pop C, right, and add the children of C in the queue. So what are the children of C? Children of C is F and G. But F is already in the queue and we are not doing duplicate checking, so we will again add F in the queue, right? So it will be C is popped and F and G are added, right? So A is visited, B is visited, C is visited. Then we do D, we pop D and we add G and H to the queue, right? So it is A, B, C, and D. Now we start with E. We pop E, and for E we have the child I, so we will add I, right? Then we have F. The childs of F is I and J, so we will add I and J, right? So it is A, B, C, D, E, F, right? Then again we will pop F. We pop F. We will pop F again. So it will be A, B, C, D, E, F, F, right? Let me just check whether that is consistent here. So we have A, B, C, D, E, F, F, right? So then again we will add the children of F, that is I and J, right? So that is I and J. Then we pop G. We pop G. Children of G is J and K. So we will put in the queue J and K, right? Then we will again pop G and we will put J and K, right? So, anyways, we are not maintaining whether a node is visited or not. I'm just crossing it off
Hmm.
for the sake of completion. So, then we visit, then we pop H. So we pop H and we add K, right? And
Hmm.
finally we pop I
Hmm.
and we add L,
L.
right?
Hmm.
Acha, what is the goal state? Acha, goal state is K. Acha. Okay, so GHI and then we will do IJ, and finally we will reach K, right? And that would be the answer. You see, it is IJ, and that is what we have: IJ, and JK. Is it clear?
Yes, sir.
So you have to remember one thing, that for BFS and so do you remember, if you remember the slides, there we had this one subtle difference between BFS and DFS, right?
Hmm.
So in between BFS and uniform cost search or any such algorithm, so the difference was that we will only pick the goal state as the final state, right? When acha, this is A star, A star, no? Let's see. When we are doing breadth first search here, we pop the frontier, right?
Hmm.
And we pop the frontier, add node to the explode for each set in action child. If child is not in explode, and if this child is a if this child is a goal state, then return the solution, right?
Hmm.
So
Hmm.
essentially, whenever we find a goal state as one of the children,
Hmm.
we return it, right?
Okay.
But in uniform cost search, only when the child is only when a node is picked for exploration,
Hmm.
right?
Hmm.
Only then it is returned as goal state.
Okay.
That is the main difference that you have to check, right?
Hmm.
So here, if you see that even if like this example was clarified here also when we did a sample run here, that if you do with breadth first search here, right? So
Hmm.
if you have to go from Shibui to Buddha Crest, and if you do a breadth first search, so you will follow this 99 plus 211 route, right? Because
Yes.
you will go from Cebu to Fagaras, and then from Fagaras you will just so you will put this and Fagaras in the queue. Then you will explore Remukui. Then you will put Pitesti in the queue. Then you will pop Fagaras and you will say I got Bucharest, and you will end up with the cost 99 plus 211. So
Hmm.
this is 300.
Hmm.
310. But if you check this path, 80 plus 97 plus 101, right? So this is 7 plus 1, 8, and this is 10 plus 9, 19, and 8, 27. So
Hmm.
this path we have a 277 length
Right.
path also.
Hmm.
But since PFS pops when it finds goal state as a child, and it does
Hmm.
not consider whether that goal state is at optimal cost or not,
Hmm. Okay.
UCS takes care of that, right? Because see, it might be the case that you add this with a cost of you have added Bucharest with the cost of 301, right?
Yes.
But in your frontier you will have Pitesti with the cost of 80 plus 97,
Hmm.
right?
Hmm.
So you will pick this one as
Yes.
the next child to explore, right?
Hmm. Hmm.
And then you from here you will see, okay, now I can go to Bucharest, and then you pick Bucharest, and then you put Bucharest with this cost 80 plus 97 plus 101, which is
Yeah.
277,
Hmm.
right? And the moment you do that,
Hmm.
the next state to explore will be Bucharest, and the queue will have Bucharest 277 and Bucharest 301 both, right?
Okay.
Then it
Uh,
will pick Bucharest
hmm.
20277, and it will tell you that okay, now I found a goal state with which is
Less.
the least cost state, so I
uh,
will return that.
okay. So first estimation and then
Huh,
you take
huh,
that.
right.
Okay.
So this
So that
you
is
have
the uniform cost, and in
that is
all the other those the DFS and BFS and other thing that is ununiform.
so BFS is like you just so if we do exploration by BFS, right? So in BFS we will just maintain the queue. We just maintain a queue and we will just add all the like we'll just add the total cost of the
Hmm.
paths. That's the final cost.
Hmm.
Whereas in UCS you have to maintain like the cost that you have explored so far,
Hmm.
and if it is indeed the lowest cost node in the frontier,
Then you have to take that.
then you
Okay.
have to
First
take this.
estimate and then okay. So,
Yeah. So this was a question on UCS. So does this
and yeah, this is fine, sir. I'll go through it. And another question is the completeness thing. I mean, if a solution exists, then that is there a question mark that this is a complete thing or not? If a solution exists, then you can find it.
if a solution exists,
Huh?
then these algorithms will always find a solution, except for depth
Find a
first search.
solution.
Except for depth first search.
Then why there is a question mark with DFS that it's complete? No,
Here it is saying BFS is complete.
no, no, no. Here it's yeah.
So DFS is not complete, right? That's what I'm saying. Except for DFS, every other algorithm is complete.
No, I mean, how do you explain this?
Yeah.
DFS is complete. No, I mean, if there is a solution, then how
Yeah.
can you say that it's not complete? If it is
So,
infinite depth, then it's not complete. Fine.
yes. The only concern is that if it is and when we talk about completeness, it is normally in asymptotic notation only.
Okay.
So when the tree is like of infinite depth, and
Mhm.
we also clarify that BFS is complete only when the breadth of the tree is finite. That is also
Oh,
considered. You see,
okay.
yes, only when B is finite.
Hmm.
Given that your fan out is not too high, like you're not generating like infinite childrens at every level, then also you will not be able to generate like you'll not be able to go to a goal state if it exists. And for random restart and those kind of algorithms, the intuition is that in one of the random restarts you might eventually generate goal state as the initial state, right? And and that's why those algorithms are asymptotically complete.
Yes.
Any other question?
No, as far as this is concerned, nothing. Sir, can you just give some idea about min max? I forgot it completely. And min max, where is the utility and where it is exactly used? That min max.
Min max.
Min max,
The
we have done it in the course, I think.
yeah, yeah. So you are talking about this now, the min max tree, alpha beta pruning, and that kind of. Uh-huh. So you want me to solve a question about
No,
that?
no, no. Just explain me. I'll go through.
So it's just like that. So the intuition is very simple that if you are at a part of tree, right, where you have established that if I go beyond this, I will pay a higher cost
Hmm.
than a part to goal which I already know, right?
Hmm.
In that case, you will simply prune this branch.
Okay.
So that was the intuition there. So you maintain alpha and beta, and
Hmm.
whenever alpha got
That is
like,
alpha beta pruning. I think.
so yeah, that was I think either it was whenever beta became greater than or equal to alpha, you prune that branch. Like okay, that means you are at a point where where you are paying more, and it's better to get out of that. Let me just pull up the slides so that we have.
Yes.
I think it was this one or maybe the next one. I have to check. Yes. Local search. No, I think it was after that. February 20. It was February 17th. So February 24th. Yeah, this one,
Yes,
right? Min
this one,
max.
yes.
So yeah, here if you see, like, we already have a path of 25, then I will pick a path that makes me yield 35, right? So we'll just not take this. We'll just prune this off. Then we push 25 up, 30, 20, and so on. And then we got a path with cost 5. So why will I even consider exploring this path of cost 30? I'll just simply prune that. So that was the idea. So the return condition is whenever beta became less than or equal to alpha, we just prune it. So alpha is the best value for max on the path, and beta is the best value for mill along the path. So these are some things that are there. Maybe you can just go over like uh,
Yes, yes,
that.
yes.
There are YouTube videos that I have uploaded, so I
Hmm.
hope you have access to that sheet, right?
Hmm. Yes, yes,
And I have also made these presentations public, so you can
yes.
go over them also. Yeah.
Today's things also you'll upload, huh?
Yeah,
Okay.
everything will be there.
Hmm. The questions will be like this. I mean, this depth. I mean, whatever the way
I have
you
that I
do
can't comment, but
in
what I
the
could.
assignments. I mean, the way we do assignment will it be of
Yeah,
that
yeah. That is
difficulty?
something that should be inherently true, right? Otherwise, why would they make you go through all these assignments without even
Yes, yes.
like?
The most confusing things are the multiple answer type
Hmm,
questions.
hmm, yeah. So you also opted for the exam.
Yes, yes.
It is on 29th.
It's
Is it?
on 29th.
Okay. All the best then.
Okay, thank you.
Okay.
Thank you. You have made most of the clarifications.
Yeah.
It has been very nice throughout.
Thank you. Thanks a lot.
Okay, thank you, sir.
So if there are no more questions, then I'll just.
Not from my side.
So anyone else, if you want to ask questions or anything, you can just ask, and then we'll just close the session.
Any
Yes.
tips for preparing for the exam? Any
I mean,
order
what
of
I
priority
see,
or
one
anything?
good thing is that they have made the solutions public, right? So I would suggest that you go through all the assignments and just solve them once before the exam,
Okay.
because I think nothing would be out of scope of what is taught. Like, I would suggest that you properly follow all the assignments that were discussed, and it should be easy to. It should not be that. It would not be that difficult. And anyways, the latter part, like from week 6 and week 7 onwards, things were like really heavy. Week 7 till week 10 was like really heavy for me, especially. After that, it was just pure math, so it did not matter that much. Yeah. Okay. So, yeah, is there any question?
Its material and solving all the assignment should be enough, or any specific material you would recommend to read?
Huh?
Any specific reference material you would recommend to read, or the course material is enough? The
No,
slide.
I would say just go through the course materials. And I mean, see, I have never taken an NPTEL exam, and I am not even the problem setter, so I have no idea. Like, just to be frank, but what I would ideally do is just go over the assignments that were given to me, and also just go over the slide material that I have. Like, because outside of it, I don't think they will ask anything. Like, they should ideally not ask anything outside of that. Then it would be problematic.
Okay, got it.
Okay, cool. Okay, so I'm just closing the session for now, and thanks for attending. And I hope you
Thanks a lot for all the help.
have a good exam. Okay, bye bye.
Bye.